Hey, welcome to the next installment of Old Farts Talking Tech. I'm your host, Matt Whalen. In the last episode, I started an electronics project to build an Arduino-based lawn sprinkler controller. I'm happy to say that the basic system has been performing flawlessly for about a month now, and I'm ready to add some bells and whistles to this, like a user interface and maybe some extra functions. I'm also happy to report that my engineering colleague and friend, Ken Kadlick, is on board with what I'm doing and has even made me some useful suggestions for additional features like a water flow sensor to detect if a sprinkler head has sprung a leak or malfunctioned somehow. But first, I'd like to answer a question one of the viewers had about how I set up the Arduino controlled relay. He asked whether I was switching the hot or the neutral AC line on the relay system. I think I can answer that with this diagram. Here's a top-level schematic of the sprinkler control system. The power to turn on the sprinklers comes from a step-down AC transformer shown at the bottom of the diagram. The input to the transformer is the house 120 volt AC. This gets converted to an output of 24 volts AC by a step-down transformer. One wire of the 24 volt AC is routed to the switchable connector on each relay connected to a sprinkler valve. In AC voltage terms, this wire represents the hot lead of the AC output. The other output wire is connected in common to all the sprinkler valves. This wire represents the neutral lead of the AC output. The digital input that controls how each relay is connected comes from the Arduino, so if the signal from the Arduino is a logic 1, the relay connects the 24 volt AC input to the selected sprinkler valve, and the circuit is completed back to the transformer through the neutral wire. Thus, we are switching the hot lead of the AC output rather than the neutral lead. Now that I've shown how the sprinkler control hardware works, I'd like to talk a bit about the Arduino software that acts as the brains and user interface. As a side note, for anyone that wants to dive deeper into this, I've created a GitHub repository for the Arduino code at the address shown at the bottom of the screen. So the current version of this software uses the Arduino Nano built-in serial interface to send text and numerical data to and from a host PC. Because of how the Arduino microprocessor buffers serial data internally, it's easy to get incorrect values sent or received if you don't manage the serial buffer. To avoid this problem, I include two snippets of code, one here and one here, before and after I enter data. The first block of code says while serial.available equals 0, puts the serial I/O port in a tight loop, waiting for the user to enter data from the keyboard. The Arduino is basically waiting for a non-zero byte to show up in the serial buffer to start accepting input from the serial monitor tool included with the Arduino IDE. The second block of code sets up another tight loop after the user has entered data via the serial monitor. This snippet checks to see if the serial buffer is empty. And if it isn't, it reads data byte by byte until it is. This ensures that there's no leftover garbage data in the serial buffer before accepting new input. As someone learning the ins and outs of Arduino programming, this particular trick took several hours of trial and error and watching YouTube videos before I hit the right sequence. So you can see here that first I'm waiting for the buffer to have a non-zero value in it before I enter a command, and then after I enter a command, I'm waiting until the serial buffer is completely empty before I go on to read the next one. And I do this before and after I enter any serial data for controlling the sprinklers. So one thing this has taught me is not to rely too heavily on the Arduino serial I/O as the only user interface. That's why in the next iterations of this project, I'll be exploring other ways of communicating with the Arduino, like Bluetooth and Wi-Fi. But at the moment, I now have a system that allows me to, number one, test each sprinkler. I can input when I want the sprinklers to start by inputting data into the start hour. I can control how long I want each sprinkler head to run, and I can also put this into auto mode when everything is set up correctly. As you can see, there's a lot more to be done with the sprinkler control system, but I think I'm off to a good start. I've also put together another quick Arduino project that's in keeping with the fall holidays, in particular Halloween. There's a bit of a story to go with this as well. From 2017 until last October, I was a senior hardware engineer at Google LA working on developing multi-camera and lighting systems for the purpose of creating lifelike avatars for VR and AR products. Early on in the project, we needed to test our system with a human-sized object to verify camera focus and lighting. Our need for this just happened to be around Halloween, so as a quick and dirty test, I bought a life-size plastic skeleton from our local Home Depot. This actually worked out quite well, until I discovered that some of the project engineers were creeped out by the presence of a skeleton hanging around the lab. Needless to say, the skeleton's modeling career was short-lived. But I've hung on to this guy, and a couple weeks ago, I figured out a way to customize him by adding NeoPixel LEDs controlled by, what else? An Arduino. Check it out. All right. So, I have this lovely Halloween skeleton that I've had for a few years, and when I first bought it, it had little LEDs that would flash right here in the eyes. But that was all. So I've been wanting to kind of kick it up a notch and add like an LED array of NeoPixel LEDs so that I can have the eyes flashing, maybe like a little heartbeat thing happening there, LEDs running down the spine, and maybe down the legs and or arms. And have the whole thing controlled by an Arduino. So, first thing I got to figure out is where to put the Arduino. And it occurred to me that there's a whole lot of space right here. So what I'm going to do is give this guy a brain. Check it out. So I'm going to take his head off. It's very easy to take off, actually. Just like that. And now, by removing the back of the skull, look what I have back here. I gave this guy a brain. Got a little Arduino Uno sitting there. So here's the Arduino. This is a 5-volt power supply. So basically, with this guy, I can plug in a 12-volt source here. It came included with a switch, so I can turn it on and off here. And then this little circuit converts a 12-volt DC input into a 5-volt DC output, which can power both the Arduino and through this guy all the LEDs, all the NeoPixel LEDs that I want. So I'm going to hook this up onto the chassis of the skeleton, and let's see what happens. And here we go. We have got Mr. Skeleton running the NeoPixel LEDs, flashing different colors, and with the battery attached to it, it will run all night like this.